I'm gonna start by going over some like accoutrements that you usually need, right? First things first, if you guys don't have them, if you're gonna be ceramicist, I recommend you get like a NIOSH approved respirator, right? Like one with one of these. These are for particulate, right? They have sort of bigger, heavier duty ones that attach to here that are for vapors. Particulate should suit you fine for what we're doing. There's a couple different kinds, like, but you should get one if you don't have one, right? Back in the day, there was like a studio one that we did, and then like after COVID, it was like, oh wait, no, that's super gross, so let's not do that. So I recommend you get your own if this is something that you think you're gonna be doing for a minute, right? I'm not going to use one today just for demonstration's sake, because it's hard to do this hour-long demo with the respirator on, right? Always be safe. Use PPE, like whatever you need, right? So that's one thing. You're gonna need a bazillion buckets, right? I usually have one totally dried out 5-gallon bucket, one totally dried out 1-gallon bucket. I have a bucket down here that's full of water, so I have stuff to clean my tools off. I've got another bucket over here that's got water in it. That way I can have clean water should I need it. You just always need more than you think you need. So one of these might be overkill, but I'd rather have more than I need than not enough, right? A drill and a paddle. If ever you're buying stuff for like your own studio, this little red paddle, I think this is from like Ace or something, right? There's like 7 different kinds of paddles. I found that these little like dinky $6 red ones work better than any of the other ones, right? So, gonna need that. Gonna need a sieve. And these for this studio are usually floating around up here. They might be drying on the sink, right? I use a brush to push glaze through the sieve. You're gonna need some kind of scooping receptacle, underglaze pencil, graduated cylinder so you can measure specific gravity. And then I usually have basically all my beige ingredients, which are mostly ingredients in ceramics, right? They'll go in here, then they'll go into this big bucket. Anything that's a colorant or that might stain, I usually will add in its own separate container. So I usually keep 1 or 2 of just like a random little container around. That way they don't get mixed. Does that make sense to everybody? Mm-hmm. Cool. Ayana, are we still good and recording over here?
Yep.
Okay, very good. Cool. So I'm going to show you guys how to mix one of the more complicated glazes today. That way from then on you can mix one of the easier glazes pretty simply, right? So first things first, these guys, this is our like Cone 6 glazes and our glaze mixing log. They live up here, should you ever need them, right? So what I started out by doing was going through the studio glazes, seeing what was low and what needed to be mixed. Usually we mix things when they get to like a quarter full, and then we'll mix a 5,000 gram batch. 5,000 gram batch is roughly a half of a 5-gallon bucket, depending on water content. So if you let it get down to a quarter and then you add half, you'll end up at like 3/4, right? Which is good because you don't want to have it all the way to the brim because then mixing gets really, really difficult, right? So we are going to find our recipe. So today we're going to mix the Fancy Pants Purple, which is one of the glazes that I made for the studio. So we have the recipe here. It's got the batch done for you, right? I want you guys to pretend whenever you're mixing glazes that this doesn't exist. Reason being, sometimes you're going to need to mix like a 7,500 gram batch or a 10,000 gram batch, right? If you just rely on the like paper to do the math for you, I don't want you guys to lose that math skill, right? Or have any questions about it. So, first things first, what we do is we find an empty page in our glaze mixing log. And these ones might all be full. Oh, we got some empty ones in the back, so let's do that, right? So glaze mixing log, and then I want you guys, one more thing, a writing utensil. I want you guys to copy over the recipe from here onto the glaze mixing log, right? I'm gonna do that here. I'm also gonna throw it up here just so it's a little bit easier to see, right? So we got material, Wolastanite, EPK, also known as Edgar Plastic Kaolin, Frit 3134. Yeah. Silica, also known as quartz. Gersley borate, which we don't have anymore. We are subbing 1-to-1 for Gillespie borate. So I'll just write Gillespie. Right, and that's our total base. And then we'll go down one. We have tin. We've got titanium. We've got cobalt. This one's got a lot of stuff in it. We've got copper. And then write what kind of cobalt and copper there are, because there's multiple kinds. There's oxide and then there's carbonate, right? So cobalt, carb, copper, carb, and this one's also got chrome. you mix any glaze that has chrome in it, you can't just use a normal scale that goes up to like 7,000 grams or what have you, right? You need like a fancy pants, like super, super precise one, because if you're off by half a gram with chrome, your glaze ends up totally different, right? This one doesn't get precise enough. This one does. This one usually lives in the office so that it doesn't end up just like lost to time, because then we can't mix any of our pink or purple glazes. But for most glazes, you'll be okay with just like a relatively normal scale, right? So you just copy all this over, right? And we go to the percentages. So 25%, 20%, 20% for 3134, 20 for silica, 15 for Gillespie borate. 10 is going to be 5%, titanium is going to be 1%, cobalt is 0.25%, copper is 0.25%, chrome is 0.02%. So like we're talking like teeny tiny quantities, right? 0.02. If you mix up the 0.02 and you do 0.2, that glaze is trash. It's a totally different glaze, right? So you would write this down and then you would move down the line on this, right? Total gram weight, yada, yada, yada. I'm gonna sort of re-explain things on here, that way everybody can sort of see and the camera can see too, right? So basically what you need is, you need your material, you need your percentage that our recipe says, right? Let's go ahead and do one of these, percentage, do one of these. We need to figure out what we need to multiply by to get the total gram weight we're looking for. We'll get to that, right? So this will just be gram weight. And then I always put a little section for check marks, right? Reason being, it's absolutely going to happen that you're halfway through doing math for a certain material and they're all kind of white or beige, so it's really difficult to tell what things are. Someone's going to come and ask you a question and you're not going to know where you were at, and then we can't just like randomly add stuff to at that point, right? We're doing chemistry, so it has to be precise. So let's do this. Let's write down our materials, right? So we'll last the night. I usually just go will last. We've got EPK. Cross like so. We've got ferrofrit 3134. Usually you just write the number down and across. We've got silica. Remember I was saying the like AKAs earlier? If you're ever unsure, floating around somewhere down here, there's a raw material subs and synonyms thing for like if a material doesn't exist anymore. For instance, like Kona F4 feldspar, we haven't had it in a long time. We use Minspar 200 as the sub for that. So if ever you're running into a recipe where it says Kona F4, you would use Minspar, right? Silica, so Gillespie borate, I'm just going to write Gillespie because that's what we're actually using. And this is sort of a recent one that ran out. It ran out a while ago, but I think Laguna had some, and then I suppose they ran out too, and then now we don't have that because the line's not there. So this is our total base recipe, right? So our percentages are 25 for will last tonight, 20 for EPK. Pardon my doctor writing too. 20 for 3134. 15. Oh, pardon me. 20 for silica, and then 15 for Gillespie borate, right? All of these numbers added together should equal 100. And then we're going to have additives. You can kind of think of those as like their own little floating island of stuff that gets added, right? These numbers for the base recipe, though, should equal 100, right? And if you add them up, they do. So equals 100. Usually in recipes, they're written like this, and then there'll be a space, and then a plus, right? So we're going to add tin ox. Let's do a little doodly bop. We're going to add titanium dioxide. Titanium diox. Go across. We're going to add cobalt. Like I said, there's multiple kinds of cobalt, so make sure you write carb, because that's what we use most often. We'll go across. Copper, carb. Across, and then chrome oxide, also known as green chrome oxide, also known as chromium. Go across there, right? So, recipes will be base recipe plus additives, right? These are all colorants. Sometimes there'll be a thing like Zircopax, that's an opacifier. That'll make things less translucent and more opaque. All of these are to get the desired sort of color that we're going for, and then a little bit of variegation in like float from like root seal, right? And that usually comes from titanium. So our percentages are 5, 1, 0.25, 0.25, and then 0.02, like I said just a minute ago, right? Now how do you figure out how many grams of each thing you need, right? You got to figure out the batch size that you're making. So for this, we're going to make a 5,000 gram batch. What you do is you take the batch size, you divide it by 100, which is what your base recipe is, right? And that gives you how much you need to multiply each of these numbers by to get the gram weight. So in our case, divide it by 100, we basically just move the decimal point over, so 50, right? So kind of think here, all of these, all the way down the line, are going to be multiplied by 50. Someone want to do math for me?
Got it.
What's 25 times 50?
1250.
1250, which means this one should be 1,000.
Yep.
1,000. 1,000. What's 15?
750.
750. What about 5? 250?
Probably. Yep.
250. Ooh.
12.5. Oh, 50.
50.
12.5.
12.5. 12.5. And this should be 1 gram, right?
It is.
Okay. So 1 gram, right? You see how little there is, which is why we're going to need the like teeny tiny little like very accurate scale. Okay. So that, now we know how to mix the actual batch size. And also, like, apologies if this is like redundant to some of you guys. Seems helpful, that way people can reference it if they need to, right? So, because we've got it written down, we don't need this anymore. We'll set this off to the side. And we'll start doing check marks as we add stuff, right? So, to get the scale set up, turn it on with the receptacle already on it. Or if you turn it on and then you add the receptacle, you can do that. Just make sure you hit tare. Make sure it's on grams because we measure everything in grams here. And then we'll start adding stuff, right? So elastomite, I need 1,250 grams. Most of these like things that equal the 100% are gonna be in our like big bins over here. Once in a blue moon, there'll be one in a small bin and you might have to get some more from the back, right? So elastomite 1250. Elastomite, we need 1250. I always like double, triple check that the material I'm adding is the material I think I'm adding, right? Ooh, pretty close, 1330. So if you overshoot it, what I usually do is take a scoop out, and I kind of just do this thing. I've always just called this like petting the turtle. You know what I mean? You're just like adding little bit by little bit until you get right to what you want, because we don't want any margin of error in this. Like, if we're shooting for 1250, let's not do 1251. You know what I mean? Is that as important with these like gray and beige minerals? No, but it's a good habit to get into so that you don't mess it up when it's a colorant or an important mineral, right? 1249, 1250. Reason I do that is because otherwise what I found I do is like scoop some out, shake it out, I overdid it again. Scoop some out, shake it out, I overdid it again. This is like the easiest way I found to make sure that I'm getting the right amount, right? So 1250, 1250, will last the night, cool. And that's just me double, triple checking everything to make sure that I'm right. So dry material from here goes into the big bucket of dry material. Try to get it low, like this when I'm pouring in. And then usually when you guys are mixing stuff, I'm not gonna do this because we're videoing, but we got a really cool fan back here that makes a really cool noise. Sometimes you gotta give it the old like, come on buddy, and it'll start working again, but that'll suck most of your materials out as you're mixing stuff, right? So, get that down to where that's empty, set it down, it's at 0 grams again. We did will last the night. Let's grab a marker that works. Big check mark, right? Again, that way if someone interrupted me right now, I could just be like, oh, okay, cool, where was I? Well, last night's done. Good. That track for everybody? Cool, cool, cool. EPK, 1,000. Double check here, EPK. Very good. And usually I wouldn't mix here, I'd be mixing over there. It doesn't work as well if I'm like back to you guys the whole time. So you wouldn't have to do the dance with the materials. So, let's see what else we got. Oof, close again. 1,077, and I'm shooting for 1,000, right? So let's take some out. Pet a turtle. 92, 97, 1,000. Double check myself. EPK 1,000, 1,000, EPK. Got that. Let's add this to our other dry material. And again, I'm not just like sloshing it in there because it's really likely to create a ton of dust. That's back at 0, which means we're good. Put a check mark. And we need 3134. And we need 1,000 grams of that. And then from here, we're kind of just like rinsing and repeating. That's 740. 984. Oh, so close. 995. That's how it usually goes. Every once in a while, you'll just like grab a random scoop, dump it. It'll be like exactly 1,000.
One of the greatest feelings.
It is. That tickles all the weird parts of my brain. 1,000. 3134. 1,000. 3134. Very good. Set this off to the side. And then I usually mark it as done once it gets added to my big bucket of dry materials. Put that here. Mark it as done. Now we're on to silica, 1,000 grams. Also, like as you guys are getting used to mixing glazes, assume each glaze is going to take you an hour. Oftentimes it'll take less than that, but I'd rather you give yourself like enough time to finish something all the way through than start 3 half glazes and then someone else has to finish. We're way more likely to make a mistake when there's like a game of telephone with projects, right? So 972, 999, 1,000, 1,000, 1,000. Silica. Add this to the bucket. Usually for this demo too, I'll choose a way easier glaze, like a clear glaze or something like that, right? But I do find it's kind of helpful to do all the like annoying part of this, right? And having to get a separate scale and yada, 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 just to sort of show you how important certain things are. We did silica. Let's grab the one that works again. All right, Gillespie borate, 750 grams. So Gillespie right here. 750. That's 530. Okay, just heads up. 756. So if you overshoot it like that, what I usually do is after that is just grab some. Just kind of do like a pinchy thing until you get to what you're looking for. 750, 750, Gillespie, Gillespie. And then you can see back here, most of the time I leave this open just so I can double check what material I'm using. Right? We got that. So basically what we've done here is this is all the materials to make a clear glaze. Right? From there, we'll add stuff to it to make it have some variegation and then to make it that really cool purple that our fancy pants purple is like. Right? So from there, what we'll probably do is switch over to maybe the smaller receptacle. I might use this one just for the tin because 250 grams is like not a ton, but it's a decent amount. Tin's back here. And also be very careful with some of these chemicals like tin, titanium, cobalt, copper. They're like $50 to $75 a pound. And so like some of our glazes end up like being quite costly because of that. So try not to like spill the whole thing of it. Because like a thing like this of certain chemicals could be like a few $100s worth of stuff. They'll have these like little scoops in them, right? So because this is a beige one, I'm gonna go ahead and keep using it here. Once we switch over to like copper, chrome, cobalt, like pink, green, those sort of things, we'll switch to a smaller receptacle. So we need 250 grams of this. So that's gonna be quite a bit. So right now we're at 150. 250. All right, perfect. Set that to the side. 250, 10, 250, 10. Very good. Right there, we'll do a check mark. And then now we gotta do titanium. That's another white one, so I think that one will be okay in here. We need 50 grams. And then double check that your scale is on. It's real easy to like be doing stuff, cleaning things out, and then you come back, start adding stuff, and it's gone off. You know what I mean? If that happens, you gotta pour everything back, reset it, re-tear it, and then keep going from there. So we're looking for 50 grams. So we're at 44. Put the turtle. 49. 51. Let's grab a smudge out. 50. Titanium 50, titanium 50, very good. Set that off to the side. In we go. Make sure that's a 0. Put a check mark. Now we'll switch receptacles to these smaller ones. Because we're using a smaller receptacle, we have to tear it back out. So we're going to use copper and cobalt. Let's grab those. Copper carbonate is pink, turns blue, like the bluest blue you can think of, very royal blue. 12.5 grams. It also means that this scale doesn't quite cut it. So let's go ahead and turn that off. Let's grab our fancy pants accurate scale. See why it's not working. This is overloaded. That's interesting. Let's tear it now. All right, 0 grams. So we need 12.5 grams. Right there is like 3.5 to sort of show you like how precise you gotta be. Really try not to overshoot these ones, if possible, right? Take your time, go slow. Right there's 10 something. There's 11. So once I get to like the last gram or half gram, I go real slow. So there's 12.3. Now we're adding just like teensy tiny little bits. So we got this, 12.5, 12.5. We'll then add this here. Another thing you can use too, depending on how much material you need for like chrome, this is helpful. Sometimes I'll just use a piece of paper. Then I don't have to be worried about like accidentally mixing my materials. For instance, if I then put copper in here, which is that green one, it's gonna have cobalt. If I overdo it and I need to pour some back, that copper is gonna be tainted with cobalt, right? Now let's add 12.5 grams of copper carbonate. So we overshot it a little bit. I'm glad I used a piece of paper, right? So we're at 12.74. Scoop just a smidge out. 12.2. 12.3, 12.4. Then every once in a while, like if you're adding stuff and it's not changing, I'll just push down on it to overload the scale. That sort of resets it. 0.5, 12.5, copper, and then you can just do that, right? And the paper stays relatively clean. You can toss it upwards. Or you can flip it over so we can do chrome. So remember, for chrome, we need just 1 gram. Because this stuff's really, really strong. The combination of chrome and tin is what usually makes pinks and purples, right? And be careful not to mix them up, which has happened before where someone put like a ton of chrome and just a little bit of tin. You get this weird like Reptar forest green, which if that's what you're shooting for, amazing. But more often than not, it's not what we're shooting for. So chrome, 1 gram. It's very strong. There we go. So we're actually at 1.06. I'm gonna try to take a teensy bit away. Right on the money. it's gonna be very difficult for you to get exact. For chrome especially, try to get as close to exactly 1. If it's like 1.01, I might let that slide because like your human hands are not gonna be able to take off 0.01 grams of something, right? So, add this here. We are done with the dry mix of our materials, right? Forgot to do it. We added copper, we added chrome. Now no one can mess us up, right? Next thing we need to figure out, for this, I'm gonna erase glaze mixing so I have a little bit more surface area to work for. How much water do we add, right? Because we mix all our glazes obviously to be used, so they're formulated with water for dipping. What I usually do is start with 75% water, 70 to 75. Reason being, most glazes need between 75 and 100% water to be the proper specific gravity. Specific gravity has a bunch of terms depending on, or a bunch of definitions depending on what you're doing, right? Like in brewing, specific gravity refers to like alcohol content. For us, what we're basically trying to do is, some people will call it thickness. It's technically not thickness, that would be viscosity, but a kind of layman way or layperson way to view it would sort of be thickness, right? We want to make sure it's the same specific gravity every time. That way a like 2-second dip is always a 2-second dip is a 2-second dip, right? So to find the 75% water, we're going to take 5,000 times 75%. Someone want to do that math for me? I think it's 3750. Yeah, 3750. So that's how much water.
So smart.
I've done it a couple times. Grams of H2O, right? For our purposes, specific gravity really is the measure of particulate plus water versus just water, right? That sounds like kind of convoluted and weird. Again, a lot of people think of it as thickness, but really it's like water content is what you're measuring. What we're shooting for in most of our glazes is a specific gravity of 1.4. So it's basically 1.4 times heavier than water would be if it took up the same volume, right? Which is why we have one of these handy dandy things right here. So this is one of the only measurements that can be a little off, right? If you don't hit exactly 3750, it's not the end of the world because we're gonna add more afterwards, right? So 0 grams. Let's take our thing of water here and we'll try to get to 3750. 35, 36, 3764, close enough. Good enough for government work, right? Set these off to the side. Now this part's important. Always, in ceramics at least, dry goes into wet. If you go wet into dry, it's really likely to clump. And then also it makes like a lot of plumage, right? So, when I'm adding something dry to wet, usually I would do this in this spray booth back here. Reason being, there's a fan next to it. It's much more powerful than this little kitchen fan, right? So this will suck a lot of material out. For demonstration's sake, we'll do it right here, and I'll just be a little sensitive, right? So dry goes into wet.
You're all set today.
Yeah. Right there, I'm good. Also, you can use gloves if you want. It's actually very difficult to absorb a lot of these materials through your skin unless you have open wounds. And most of these materials are completely inert. You're like heavy metals like manganese and stuff, you might want to be a little bit more particular about, but even that, you'd have to like try to get any sort of lethal or toxic dose of manganese into your skin. Your skin just like doesn't absorb powders as easily as it does like liquids, right? So let's get this a little pseudo mixed up there. Then we'll switch over and use our drill. The viscosity is sort of tricky, right? One reason is it takes a minute for these materials to A, combine together, but B, some of these materials take like 24 hours to fully absorb all the water. So things may be really, really thick today, and then you like dip a test towel and you go, there's no way this is gonna work, and then tomorrow they might be perfect, right? So that's something to be mindful of. And then one thing I should have mentioned that is helpful for you guys to have is some kind of spatula or something like that, right? I'm gonna go ahead and use my brush here just to scrape down the sides for any of that dry material that didn't want to get mixed up from the get, right? And I can see just looking at this, It's real thick. I'm not fully trusting my eyes again because things like thin out over time. Sometimes things get thicker over time too, so just something to be mindful of. So set this off to the side, clean this. This is another rule that I think is really helpful. You're doing anything with glaze, or especially you're doing anything with slip or plaster, clean your tools just like the second you can, otherwise it becomes much more difficult. So looking at this, I can see that it's acting a little bit more like paste than it is like a liquid, right? So I can sort of assume it's gonna need a little bit more water. You don't wanna overdo it. I'm just gonna add a smidge here. I don't usually measure this part. I get it closer to what I think it should look like. And then I'll start to measure it scientifically, right? Otherwise, we're gonna be here all day like measuring. Okay, we're off, add a little water, mix it, measure. Okay, we're off. It takes a long time. What I do is kind of eyeball it close, and then we'll be scientific. Usually on a finished glaze, right, what I'm shooting for is I want to be able to mix it really vigorously with a paddle like this, and I want it to spin a few times, and then slowly come to a stop. If you're ever mixing something and it goes and like freezes and acts kind of like paste, it's probably too thick, or it's got flocculence in it, and you know there's a bunch of other things there chemically that could be happening. More often than not, now it's on water. So we've got a graduated cylinder here. Let's tear it out. This one goes up to 250. If ever you have the option, like we also have a 100 milliliter one, use the biggest one you have because it allows you more room for error. If you're off by like this much on 100 milliliter, it can have quite a big difference on what your specific gravity reads. If it's a 250 or a 500, you have more room for error because you're never going to nail it perfect, right? I lied. Let me use that one. Make sure these are dry, or as dry as you can kind of muster quickly, because we're measuring the ratio of particulate plus water versus what water would be. If there's water in your pouring receptacle, that'll mess you up, right? So this is teared out. If you tear something out, you can remove it and then add your stuff and then set it back down, right? So what we're gonna be shooting for is filling this right up to this 250 milliliter line. Reason being, 250 milliliters of water should weigh 250 grams. Granted, that I'm sure depends on the alkalinity of your water and what like chemical additives the city has added to it, but that's sort of the assumption that we operate off of. And I can tell just by pouring this is like real thick, but I could be wrong and it could be perfect specific gravity, but the viscosity is off, right? So it's at 363 here. I'm almost at 250. Once I get close to where I'm shooting for, I'll then come to the side. I'll usually cup underneath it because if you get drips, that's gonna throw off your measurement as well. Fill it right up to 250. Maybe a hint more. That seems good there, right? So my total gram weight is 373. If we're trying to measure what particulate plus water versus water is, we take 373 and we divide it by 250. Will one of you do that for me, please? It's probably like 1.5.
373 divided by 250?
Yeah.
1.5.
1.5, right? That's your specific gravity. So you're taking what water would weigh if it was filled up to the same volume, which would be 250, right? You take what this actually weighs, divided by 250. This is 1.5 times heavier than water would be. And that's what specific gravity is for us, right? What we're shooting for is 1.4. So I have a little bit of wiggle room to add more water to this, which is good because pouring it seems crazy, crazy, crazy thick, right? So add this back. Try to get all the gunk out of it. And again, all this stuff kind of has to be cleaned out in between. Let me show you the easiest way to clean out a graduated cylinder. And then again, you want your tools to not have water in them because that'll throw off your measurements. So try to get it as dry as you can without, like, we're not saving lives here, you know what I mean? This is like so it glazes a little thinner. So I'm not as concerned about getting it 100% perfect, but always try to be a good scientist. And then I don't usually measure how much I'm adding each time. If it makes you feel more comfortable, and I don't, because I've been doing this long enough, do it like 500 milliliters at a time, and then measure it, and then 500 milliliters, and then measure it. And you can sort of get a rhythm of how much water will adjust it, right? I probably added like 750 to 1,000 milliliters there. I have a feeling that'll be pretty close to what we need, but that's just because I've done it a lot. And then anytime you add water, mix it pretty vigorously, right? And then I'm gonna mix with this. That way the stuff that was stuck to the sides of this doesn't mess up my measurements. We're gonna put graduated cylinder back on this bad boy, and then we're gonna do it again. So it's tared. Let's fill up to 250 again. So we're gonna get pretty close. Now stop. Set this down. And then we'll add little teensy bits. Right there seems pretty good. Now we're at 354. So if you will measure that, I'm pretty sure that's right at 1.4. So 354 divided by 250?
Yeah.
1.416, right? That's close enough, right? Like we're not saving lives. This isn't rocket surgery. So we'll call it here. It still looks pretty viscous, right? So we'll check on it again like the next day just to make sure it doesn't seem crazy viscous. Because then we may need to adjust it. So most things are 1.4. We've got some here that have special gravities. For instance, like Odyssey Clear is 1.35, Odyssey White 1.35, Palm Blue, Chunceladon is 1.5. A lot of the glazes that are really runny, we like to do them a little bit thinner than you usually would because we're like a teaching studio, and sometimes people will do like a 1, 2, right? When you should be at like a 1 and a 2 and out. So to account for that, we make certain things a little thinner just because we lose a lot of pots and shelves if we don't, right? And that's our glaze, right? One more thing you'll need is we need to do a test tile. Granted, this test tile isn't going to be the most incredibly accurate because the viscosity is high on this, right? So I'm not going to do a 1 and a 2 and I'm going to go kind of quick. I'm really just trying to get the color. We do need a sieve. So we'll take an 80 mesh will do you pretty solid for almost everything. If you're mixing a glaze that has a ton of iron in it, we have 40 mesh sieves. It's basically just like bigger openings. That way iron can get through if it needs to. Because some glazes that have a ton of iron, you'll be there for like 40 minutes scraping stuff through. Pull this through. 80 mesh is kind of like the happy medium. All right, push that stuff through. And the last thing we'll do is there's a bunch of material that's going to be stuck into here. I'm going to grab, not a ton, but just a little bit of water. Put it in there. Give it a good swirl so we can get the last remnants of that material. Will this make the specific gravity drop? Yeah, but I barely added any water. So we'll be at like 1.39 instead of 1.41, right? Acceptable. Set this off to the side. Finish pushing this stuff through. Basically, what you want anything that gets stuck by the sieve, for the most part, you want to kind of push it through the sieve and make it a smaller particle size, right? Give it one more mix because we added more water to it, right, when we were sort of doing everything. Swirl, 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 slowing down, slowing down. There we go, right? It didn't freeze, and that's what we're shooting for. In and out. Get the excess off. Pay attention to how your piece glazes, right? If it glazes pretty nicely and it dries really quickly, you can go in for like a lip dip. Because that'll sort of give us an example of like, all right, if it's thin, and then this, instead of being heavy, is probably more close to what a proper like 2-second lip would do or whatever, right? We set that off to the side. We grab our trusty underglaze pencil. We're gonna write just copious notes because we're passing this off to somebody else, right? When we put it back there, someone's gotta fire it, someone's gotta take it out and check it out. That'll usually be me, right? And you can see I've got a bunch of test tiles here that other people have done from their glazes. I'm usually the one that goes through and goes like, yep, that's right, no, that's wrong, so on and so forth. If you ever come in and there's a glaze bucket over here and it's got a test tile on it, that's sort of my way of being like, marry these glazes. It's passed all our tests. It can go back onto the floor, right? So, what do we need? We need Fancy Pants Purple. So I'm just gonna write fancy. Specific gravity, we'll say 1.4. I'm pretty sure that's where we're at, right? Today's date.
30.
32? 33?
23.
23. 23, 25. Your name, Ty. And that should be good, right? Enough info to where when someone else sees this, this is the same info we're gonna write on a note and put on the bucket so they can go, Fancy 1.423 tie, it'll say the same thing here. They'll know that this matches this, right? Reason we do that is sometimes people mix glazes before checking what everyone else has done, right? So there'll be 2 batches of chun. If there's not copious notes on things, we don't know which one matches to which, right? So in this, I'm gonna leave similar notes to what I wrote on the bottom of that, right? So, all right. Fancy pants, 1.4, my name, the date, 2, 3, and then testing, which means we've made a test tile, it's ready to go. I usually write sieved on here as well, because these should all be getting sieved now, and then when we marry the glaze, it'll get sieved again. Double sieve is like really your best case, right? So sieved, testing. And like when I like harp on everybody for like put all the info on your notes, like please do. It makes the world go round as far as the studio is concerned, because there's so many of us. I mean, I think you guys make 30 different folks that like work in the studio, either as instructors, studio assistants, resident artists, so on and so forth. It's very, very helpful to have just like a ton of info. Then if something's wrong with this too, I know like, all right, cool, I gotta talk to Tyler. Which isn't like a, ooh, you're in trouble kind of thing, but then we can sort of deduce together like what may have gone wrong, here's what we could do next time to make sure that doesn't happen, okay? Is that track? Mm-hmm. Does anyone have any questions? No, it's just like so good and so concise. Yeah, okay, good. Awesome, guys. That's that. We gotta clean up and stuff, but for the most part, that's mixing glazes.